Okay, so now if we have a function that is given to us in this form, where we have x minus h whole squared plus k, then we can find the vertex directly as h comma k, right? So if we're given a function such as this, then we can directly find the vertex to be this ordered pair, right? And we know that this function is obviously a quadratic function, right, as we explained previously. So we looked at a function that was of this form, x minus 6 whole squared minus 4, right? So obviously this function um, is of this form, right? So we can very easily and directly find the vertex of this function as 6 comma minus 4. So in this case, h is equal to 6 and k is equal to minus 4, right? So then we can easily plot the graph of this function directly by finding the vertex. So the vertex will be somewhere here, which is 6 comma minus 4, and then we can just draw the graph of this function, right? So now let's take a look at another function. F of x is equal to square root of x plus 5 minus 3, right? So we're given a function such as this. Now, because of the square root, you can see that this is a root function. So it's some sort of root function. And we know that the graph of a root function, so we looked at in the previous case, we looked at the graph of the square root of x, and we know that the graph of this function looks something like this, right? It continues to increase like this, right? So now, as you can see here, so for this function, we're adding 5 units to the variable x inside of our function, right? So that means that we're going to be shifting the graph of this function by 5 units to the left, right? And then we're subtracting 3 units from the function itself. So because of this, we're then going to be shifting the graph vertically downward by 3 units. Right, so if we were to do this, so starting from our origin, if we go to the left by 5 units, so let's say this is 5, x is equal to 5, and then we go down, sorry, this is minus 5, and then we go down by 3 units. So we will arrive at a point over here, right? So the graph will start from here, and it will be easier for us to graph this function if we find out the x and y intercepts of the function that is given to us. So let's find the x-intercept first. So we have, to find the x-intercept, we set y to be equal to 0. So that means we have the square root of x plus 5 minus 3 is equal to 0. This becomes to be equal to 3. And then we can take the square of both sides to give us x plus 5 is equal to 9, which we can then solve for x to be equal to 4, right? So when x is equal to 4, y is equal to 0. So our x-intercept will be somewhere here. So this is 4 comma 0. Right, so now let's find the y-intercept. So to find the y-intercept, we set x to be equal to 0. So when x is equal to 0, we have f of 0 to be equal to 0 plus 5 minus 3. That gives us square root of 5 minus 3. Right, so our y-intercept will be 0 comma square root of 5 minus 3. Right, so when x is 0, y is equal to this. So now we can plot these points, and if we do that, we will see that the graph will look something like this. Right, and this this y-intercept will have the coordinates 0, root 5 minus 3. Right, so this is the graph of this function. Okay, so now let's take a look at another function. So we now have an absolute value function. Let's say we have f of x is equal to the absolute value of x plus 2 plus 1. Right, so once again, we have previously taken a look at the graph of an absolute value function such as this, and we know that the graph of this function will look something like this. Right, so now let's take a look at this function again. We're adding 2 units to our variable x in our function, so that means we're going to be shifting this graph by 2 units to the left. Right, and now then we're adding 1 unit to the function, so then we will shift the graph upward by 1 unit. Right, so if we were to do this, we would have, so 2 units to the left will be here. We have minus 2 comma 0, and then we will go up by 1 unit to arrive at this point. So this point has minus 2 comma 0, minus 2 comma 1, and so the graph will look something like this. Right, so this will be the graph of this function. Now we can draw the graph another way. So let's first find the x and y intercepts of this function. So to find the x-intercept, what do? We just set our output y to be equal to 0, right? So we have the absolute value of x plus 2 plus 1 equals to 0. Subtracting 1 from both sides, we have the absolute value of x plus 2 is equal to minus 1. Right, and now we're supposed to solve this equation for x. But how do we solve this equation for x? We know that the absolute value of some number, if x is greater than or equal to 0, cannot give us something negative, right? If x is positive or non-negative and we take the absolute value of that number, then we cannot get something negative, right? So if I take the absolute value of minus 2, if I take the absolute value of 2, I can never get something negative, right? This is not possible. So whenever I take the absolute value of something, I get something that is non-negative, right? So from this, we know that in this case, we're taking the absolute value of x plus 2, and yet we're getting something negative, and this is not possible. So there is no x-intercept in this case. So for this function, there is no x-intercept. Now similarly, for the y-intercept, we set our x value to be equal to 0. So when x is equal to 0, we have f of 0 to be equal to 0 plus 2 plus 1. So we have 2 plus 1, which is just 3. Right, so when x is equal to 0, our output is 3. Y is equal to 3. So this is our y-intercept. Now, by looking at this function, or this absolute value specifically, if x is greater than or equal to minus 2, then in that case, the absolute value of x plus 2 will always be equal to x plus 2, right? So let's say we have x to be equal to minus 2. Then in this case, we have minus 2 plus 2, which is equal to the absolute value of 0, which is equal to 0, right? So whatever is in our absolute value, we will just get that back. Right, so if x was equal to minus 1, I would have the absolute value of minus 1 plus 2 would be the absolute value of 1, and that will be equal to 1, right? So So in this case, when x is greater than or equal to 2, f of x will be equal to the absolute value of x plus 2 plus 1, which will be x plus 2 plus 1, and this will be equal to x plus 3. Right. So all values of x that is greater than or equal to minus 2, we will have the graph of this function. So we will be drawing y is equal to x plus 3 for this interval. However, if x is less than 0, then we will have the absolute value of x plus 2 to be equal to minus x plus 2, meaning we will have minus x minus 2. All right, and we can show this. So let's say x is equal to minus 3, then we have the absolute value of minus 3 plus 2, and this gives us the absolute value of minus 1, and then we get 1. Right. So when we have minus 1 in our absolute value, we get 1. So the sign flips. So similarly, if we take the absolute value of x plus 2, we will get the negative of x plus 2, and we will have minus x minus 2. So when x is, okay, so I made a mistake here. This should have been minus 2. So this was the case for when x is less than minus 2. Previously, we looked at the case when x is greater than or equal to minus 2. And now in this case, this is for x is less than minus 2. So when x is less than minus 2, we will have f of x is equal to the absolute value of x plus 2 plus 1 to be equal to minus x minus 2 plus 1, which will be equal to minus x minus 1, right? So for this interval, the graph that we will draw will be y is equal to minus x minus 1, right? So let's clear all of this up. So once again, for x is greater than or equal to minus 2, f of x will be x plus 3, right? Or y will be equal to x plus 3. And if x is less than minus 2, then y is equal to f of x will be minus x minus 1. So we will be drawing these two graphs for these two intervals. So let's do that. Let's say this point is minus 2, right? So let's consider the portion where x is greater than or equal to minus 2. So for this case, let's draw the graph of y is equal to x plus 3, right? So we know that the graph of y is equal to x plus 3 will look something like this, right? The intercept will be at 0, 3, right? This will be our intercept, right? So we will draw the graph for x plus 3, and it will be something like this. Right. Now this is only applicable for when x is up to minus 2. Now for when x is less than minus 2, so for this portion, we will draw the graph of minus x minus 1. So the slope for this graph is negative, since the coefficient of x is negative. So the graph for minus x minus 1 will be like this, where this point is our y-intercept. We have 0, minus 1, right? So let's draw this graph. We will have a graph that looks like this, right? So once again, this portion of the graph is only applicable for when x is less than minus 2, and this portion of the graph is only applicable when x is greater than or equal to minus 2. So we should rub this part out. So our graph for the function will look like this.